The National Electrical Code (NEC) serves as the primary standard for electrical installations in commercial buildings, establishing minimum safety requirements for electrical systems, including the specification of acceptable equipment types. For places of assembly, NEC Article 518.4 mandates that electrical equipment must be listed and labeled, which means the equipment has undergone testing and approval by a nationally recognized testing laboratory. For commercial buildings that are not places of assembly, NEC Article 110.3 B stipulates that electrical equipment shall be installed and utilized in accordance with any instructions included in the listing or labeling. This underscores the importance of adhering to the designed and approved purpose of the equipment. To determine building occupancy, the International Building Code (IC) is generally consulted. The IBC provides a table detailing the maximum occupant load for diverse building types and spaces, factoring in the square footage of the area and the activities planned within it. For restaurants, the IBC uses a calculation of 15 square feet per person. For conference rooms, a calculation of 25 square feet per person is applied. These figures presume the spaces will accommodate general seating and conversation. In navigating electrical installations in commercial buildings, it's essential to differentiate between places of assembly, which require listed and labeled electrical gear according to NEC Article 518.4, and other commercial buildings where NEC Article 110.3 B dictates adherence to the equipment's listing or labeling instructions. Calculating the allowable occupancy within these spaces requires reference to the IBC, which provides specific square footage per person ratios based on the space's intended use. For example, restaurants typically use 15 square feet per person, while conference rooms use 25 square feet per person. Understanding the requirements within NEC Article 518.4 is crucial when dealing with electrical equipment in places of assembly. It specifically points out that the equipment must be listed and labeled. Listing and labeling, in this context, implies that the equipment has been rigorously tested and certified by a nationally recognized testing laboratory, NOTL, ensuring it meets the safety standards necessary for such environments. When it comes to other commercial buildings that do not fall under the umbrella of places of assembly, NEC Article 110.3 B plays a pivotal role. It lays out the principle that electrical equipment should be installed and used in strict accordance with the instructions that come with its listing or labeling. In essence, this means that the equipment's application must align with its design purpose and the approvals it has received. Building occupancy is a critical aspect of building design and safety, and it is most commonly guided by the International Building Code (IBC). The IBC provides a comprehensive table that outlines the maximum occupant load for different building types and spaces. This calculation is deeply rooted in factors such as the square footage of the space and the kind of activities that are expected to take place within it. When determining the square footage calculations for occupant load, specific ratios are employed based on the type of space. For instance, in the case of restaurants, the IBC uses a calculation of 15 square feet per person. For conference rooms, the calculation is 25 square feet per person. These calculations are derived from the understanding that these spaces will be primarily used for seating and conversation. The NEC is updated on a 3-year cycle, so it is crucial to use the latest edition. State and local jurisdictions often adopt the NEC, but they may also make amendments to it, so it is important to check with the local authority having jurisdiction, OJ, to determine the specific requirements in your area. Similarly, the IBC is updated regularly, and local jurisdictions may have their own building codes that differ from the IBC. In some areas, there might be local amendments or regulations that further specify or modify the requirements outlined in the NEC and IBC. These local adaptations can be due to regional factors or specific safety concerns within the community. To ensure compliance, consulting with the local authority is crucial. They can provide clarification on the specific requirements that apply to your project. The NEC and IBC are not standalone documents, and they often reference other standards and publications. These references can include standards from organizations such as the Institute of Electrical and Electronics Engineers, i.e., the American National Standards Institute (ANSI), and the National Fire Protection Association (NFPA). Being aware of these reference standards and understanding how they relate to the NEC and IBC is vital for a complete understanding of the electrical and building code requirements. The NEC provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical installations. Understanding these requirements is essential for ensuring a safe and compliant installation. For example, the NEC specifies the types of wiring methods that are permitted for different applications, such as rigid metal conduit, electrical metallic tubing, and non-metallic sheath cable. It also specifies the minimum size of conductors that can be used for different opacities. Overcurrent protection is another critical aspect of electrical safety, and the NEC provides detailed requirements for the selection and installation of overcurrent protective devices such as circuit breakers and fuses. Grounding is also essential for electrical safety, and the NEC provides detailed requirements for grounding systems, including the size and type of grounding conductors. The IBC covers a wide range of topics related to building safety, including fire safety, structural safety, and accessibility. Understanding these requirements is essential for ensuring a safe and compliant building. For example, the IBC specifies the fire resistance ratings for different building elements such as walls, floors, and roofs. It also specifies the requirements for fire protection systems such as sprinklers and fire alarms. Structural safety is another important aspect of building design, and the IBC provides detailed requirements for the design and construction of buildings to resist wind, snow, and seismic loads. Accessibility is also a key consideration, and the IBC includes requirements for making buildings accessible to people with disabilities. Both the NEC and IBC are complex documents, and it can be helpful to consult with qualified professionals to ensure compliance. Electrical engineers, electrical contractors, and building inspectors can provide valuable assistance in navigating the codes and standards. They can help you understand the requirements that apply to your specific project and ensure that the installation is safe and compliant. When determining the appropriate electrical gear for a commercial building, one must first ascertain whether the building qualifies as a place of assembly, as defined in NEC Article 518. If the building is designed or intended for the assembly of 100 or more persons, then it falls under this classification, and all electrical equipment must be listed and labeled by a nationally recognized testing laboratory, NOTL. For commercial buildings that do not meet the criteria of a place of assembly, the selection of electrical gear is guided by NEC Article 110.3. B, which mandates that equipment be installed and used in accordance with the instructions included in its listing or labeling. This means the equipment must be used for its intended purpose and in the manner it was designed and approved. To determine the building occupancy, it is imperative to consult the International Building Code (IBC), which provides a table specifying the maximum occupant load based on the building type and space usage. This calculation is dependent on the square footage of the space and the activities that will occur within it. The square footage calculations for occupant load vary depending on the type of space. For instance, restaurants typically use a calculation of 15 square feet per person, while conference rooms use 25 square feet per person. These calculations assume that the space will be used for general seating and conversation. When assessing the suitability of electrical equipment for a commercial building, a key distinction lies in whether the building is classified as a place of assembly under NEC Article 518. If it is, the electrical equipment must be listed and labeled, signifying its approval by a nationally recognized testing laboratory. This requirement ensures that the equipment meets stringent safety standards for such environments. For commercial buildings that do not qualify as places of assembly, NEC Article 110.3. B comes into play, directing that electrical equipment be installed and used according to the instructions provided in its listing or labeling. This emphasizes the need to adhere to the equipment's intended purpose and approved application. To accurately determine building occupancy, one must turn to the International Building Code (IG), which offers a table outlining the maximum occupant load based on building type and space usage. The calculation is based on the square footage of the space and the anticipated activities. The square footage calculations for occupant load differ based on the type of space. Restaurants typically employ a calculation of 15 square feet per person, while conference rooms use 25 square feet per person. These figures are based on the assumption that the spaces will be primarily used for seating and conversation. The NEC provides specific guidelines on the installation and use of electrical equipment in hazardous locations. These locations are classified based on the type of hazard present, such as flammable gases, vapors, or dusts. The NEC specifies the types of equipment that are permitted in each class of hazardous location. The NEC also includes requirements for emergency systems, such as emergency lighting and standby power systems. These systems are designed to provide power and lighting in the event of a power outage. The IBC includes requirements for fire resistance rated construction. These requirements are designed to prevent the spread of fire from one area of a building to another. The IBC also includes requirements for fire suppression systems, such as automatic sprinklers. These systems are designed to extinguish fires quickly and effectively. In addition to the NEC and IBC, there may be other codes and standards that apply to commercial buildings, such as energy codes and accessibility standards. It is important to be aware of all applicable codes and standards and to ensure that the building is designed and constructed in accordance with these requirements. When selecting electrical equipment for a commercial building, it is important to consider the following factors. Firstly, the voltage and current requirements of the equipment must be compatible with the building's electrical system. Secondly, the equipment must be listed and labeled by a nationally recognized testing laboratory, (NRTL). Thirdly, the equipment must be suitable for the environment in which it will be installed. Fourthly, the equipment must be installed in accordance with the manufacturer's instructions. When determining the occupancy load of a commercial building, it is important to consider the following factors. Firstly, the square footage of the space must be accurately measured. Secondly, the type of activity that will be taking place in the space must be determined. Thirdly, the applicable occupancy load factors from the IBC must be used. Fourthly, the occupant load must be calculated in accordance with the IBC. The NEC and IBC are constantly evolving to reflect new technologies and safety concerns. It is important to stay up to date on the latest changes to these codes and standards. You can do this by attending industry conferences, reading trade publications, and consulting with qualified professionals. The type of electrical gear suitable for commercial buildings hinges on the building type and its intended occupancy. The determination of building occupancy is guided by the square footage of the space and the nature of activities within. By diligently following the guidelines outlined in the NEC and IBC, one can guarantee that electrical installations are not only safe but also fully compliant with the necessary requirements. The information contained within the NEC and the IBC is intricate and comprehensive. For anyone involved in electrical installations or building design, consulting with qualified professionals is highly recommended to ensure full compliance. These experts bring a wealth of knowledge and experience, assisting in navigating the complexities of the codes and ensuring that all installations adhere to the highest safety standards. When evaluating the square footage of a space for occupancy calculations, it is crucial to consider the net usable area. This means subtracting any areas that are not accessible or usable by occupants, such as restrooms, storage rooms, and mechanical rooms. The net usable area provides a more accurate basis for determining the maximum occupant load. In addition to the general occupancy load factors provided by the IBC, there may be specific requirements for certain types of spaces. For example, assembly areas such as theaters and auditoriums may have more stringent requirements due to the higher concentration of people and the potential for overcrowding. It is important to consult the specific provisions of the IBC for the type of space in question. The NEC and IBC are not static documents, and they are regularly updated to reflect new technologies, best practices, and safety concerns. Staying current with the latest editions of these codes is essential for ensuring compliance and maintaining a safe building environment. Many jurisdictions offer training programs and educational resources on the NEC and IBC. These resources can be valuable for understanding the codes and their application. Additionally, professional organizations such as the IEE and the NFPA offer certifications and continuing education opportunities for electrical and building professionals. The NEC provides detailed requirements for the installation of electrical equipment in damp or wet locations. These requirements are designed to protect against electrical shock and corrosion. The NEC also includes requirements for the installation of electrical equipment in areas subject to corrosive substances, such as chemical plants and wastewater treatment facilities. The IBC includes requirements for the installation of fire-resistant doors and windows. These requirements are designed to prevent the spread of fire through openings in walls and floors. The IBC also includes requirements for the installation of smoke barriers and fire dampers. These devices are designed to prevent the spread of smoke and fire through ductwork and other building systems. The process of determining the appropriate electrical gear and building occupancy involves a multifaceted approach. Firstly, identify whether the building is a place of assembly, as per NEC Article 518. If so, ensure all electrical equipment is listed and labeled. For other commercial buildings, adhere to NEC Article 110.3. B. Using equipment as instructed in its listing. Secondly, consult the IBC to determine maximum occupancy based on the building type and space usage. Thirdly, accurately calculate the square footage, keeping in mind that restaurants use 15 square feet per person and conference rooms use 25 square feet per person for occupancy calculations. By considering these factors, you can ensure safety and compliance in commercial buildings.